Friends, let's understand about the parallel axis theorem. So suppose we have got a body. For simplicity, I am considering a planar body which is in the form of a plane, or we can say we are considering a planar body, something like this, friends. Okay, so this is basically a body which is in the form of a plate. I have taken an irregular shape of the body. It is like a plane over here. Now we would like to find the relationship between the moment of inertia of body about two axes. Okay, so let's say that we have got a point. So this is the center of mass of this particular body which is in the form of a plane. So we have considered a plane body, or we can say the plane lamina, which is having center of mass at point C. And let's say that there is an axis of rotation passing through this particular point which is center of mass of the body and perpendicular to the plane of the lamina or plane of the body. So this is the axis of rotation, friends. It is passing through the body like this. It's perpendicular to the plane and body is rotating about this particular axis, let's say like this. So the moment of inertia of this particular body about this axis will be called as IC. C is the center of mass of the body, right? Now the moment of inertia of this particular body about this center of mass is IC. So let's consider another axis. So this axis is again perpendicular to the plane and this axis is parallel to the axis passing through the center of mass. So let me call this point as point O. So now here we got two axes. One is passing through the point O and another is passing through the point C, which is center of mass of the body or the lamina. So C is the center of mass. Let me write down here. So the moment of inertia of this plane body or plane lamina about this axis which is passing through the center of mass C is IC, and the moment of inertia of the same body about this axis which is passing through the point O is IO. Now both these axes are parallel to each other, and let's say the distance between these two axes, this distance, friends, let me call it as h. Now we have to find the relationship between the moment of inertia of this body about this axis, that is IO, and the moment of inertia of the same body about an axis passing through the center of mass of the body. So this relationship we have to find. It means we have to find the relationship between IO and IC. Let me say that the mass of the body, the mass of entire body is m. So m is the mass of the body, that is I can say total mass of the body. And if we assume the distribution of mass to be uniform, so let me consider a small mass here, and this mass is very small, so I am going to call it as infinitesimally small mass. So this small mass is dm, friends. Okay, I have considered a small mass dm at certain distance from point C. So this distance, the distance of small mass dm from point C, let me call this distance as r, small r, and we can also find the distance of dm from this particular axis, that is from point O. So let me call it as capital R. Mind it, both are variables. This capital R as well as small r both are variable because the location of dm is going to change throughout the body. Okay, I have considered an arbitrary location, but this location is not fixed. It means dm can be anywhere in the body. So if dm can be anywhere in the body, these values of capital R and small r will keep on changing. So let me first find the moment of inertia of dm about this axis. So we can say that moment of inertia of dm about an axis passing through point O. So I am just taking the moment of inertia of dm, that is small mass. So that will be very small moment of inertia DIO. Okay, and that will be, friends, distance square times dm, so that will be r square times dm, as we have discussed in the previous video. Now if I want to find the moment of inertia of entire body, so I will have to integrate this. So therefore I can say the moment of inertia of body about axis passing through point O, that is this axis, friends. So that will be simply, if you integrate this part, you will get overall moment of inertia of the body. So this is basically IO, which is nothing but integration of r square dm. That's very simple. Now similarly, I can find out the moment of inertia of the body about an axis passing through the center of mass, that is C. So similarly, we can write down moment of inertia of body about an axis passing through center of mass, that is point C, So that I'm going to call IC, and that is straight away the distance is r and the mass is dm, so integration of r square dm. That's okay. This is the equation 2 we got. So if you see carefully here, if I extend this line and if I drop a perpendicular from here like this, friends, so this is going to be 90 degree. So if you simply extend this, this is going to be 90 degree, and this point let me call it as point P. So I can easily apply Pythagoras theorem. So let me call this point where dm I have taken as point Q, so that we can apply Pythagoras theorem here. So we can say that OQ square equals OP square plus QP square. So in triangle OPQ, angle P is 90 degree, as you can see from here. So therefore from here I can write down by Pythagoras theorem OQ square equals OP square plus QP square. So if you simplify this further, this OQ is nothing but OC plus CP. If you simplify this further, you can say that this OP square, which is from here to here, is the sum of OC plus CP. So this I can simplify as OQ square equals OC plus CP the whole square plus QP square, friends. And if I expand this, this is going to be OC square plus 2 times OC times CP plus CP square. The expansion of A plus B the whole square I have used, so A square plus 2AB plus B square. Okay, and here QP the whole square will be as it is. Please remember, we have used the expression A plus B the whole square, which is A square plus 2AB plus B square. Okay, so the same expression I have used here. Now if you look at this particular term, which is CP square plus QP square, so this is CP, friends, this one is CP, and this one is QP, as you can see from here. So CP square plus QP square is nothing but CQ square. So instead of this I can write down CQ square, right? So you will be getting a very simplified expression, that is OQ square equals OC square plus 2 times OC CP plus CQ square. Now let me substitute the values. So OQ is nothing but capital R, OC is H, the distance between two parallel axes, again 2 times OC is H, and CP, we don't know the value of CP, so I'll keep CP as it is, plus CQ square. This CQ square, CQ is small r square, friends. Now I'll be multiplying both sides. By dm, that is small mass, and integrating. So if I do that, we will be getting a simplified expression. So I'll multiply both sides by dm and integrate it. So we'll say that multiplying by small mass dm and integrating. Let's see what we get. So if I do that, I'll be getting a simplified expression as integration r square dm equals here h square dm plus integration 2h cp, integration of 2h times cp, distance cp, that is this distance, into dm. So here if you see, so this is going to be 2h into cp into dm, plus over here if you see, it will be integration of r square dm. Now let's see each and every term what we got here. So if you look at this particular term, friends, this particular term is nothing but the moment of inertia. This particular you can see here. So it is moment of inertia of the body about this axis, okay, that is IO. Is that fine? Now if you see this particular term, r square dm is nothing but this term, that is moment of inertia of body about this axis, which is passing through its center of mass. Okay, so I can write down that also. Now here this particular term is very interesting. So h is constant, this particular h is constant, friends, so it will come outside the integration, and this will be integration of dm. Okay, so if you see this particular term h square dm, I can take h square outside and then integration of dm, that is infinitesimally small mass we are integrating. So that will be nothing but h square into the total mass of the body, right, m. So friends, now if you see here, this 2h is constant, it will come outside. So inside it will be having Cp into dm. So this is basically mass into distance, that is moment of mass, right, about this particular axis. So if I take this distance, that is Cp, okay, so the Cp is not going to connect mass with the axis. It means this moment does not exist, that is going to be 0. So friends, we got each and every term of this particular expression. So let me write down the expression of each term. This term is nothing but the moment of inertia of body about this axis, that is parallel axis. So this is, I can write down as IO equals, so next this term I'm going to write down. So I'll write down r square dm. So r square dm is moment of inertia about an axis passing through its center of mass. I'll say it is IC plus, now this part we have discussed, it is nothing but h square, that is distance between these two parallel axes, that is h square into the mass of the body, h square time the mass of the body. And this particular term I have explained that this moment does not exist, so this is going to be 0. So I got this particular expression. So this is the final expression of parallel axis theorem. So let's first understand what this theorem says. So this theorem says that the moment of inertia of a body about any axis, any parallel axis, is sum of the moment of inertia of same body about an axis which is parallel to the given axis and passing through center of mass, plus the product of square of distance between them and the mass of the body. So this is very important, friends. Okay, so if in the sentence if you want to write, it's very simple. The moment of inertia of any body about an axis is sum of the moment of inertia of the body about a parallel axis passing through its center of mass. Okay, this is parallel to the given axis, and the product of the mass of the body and square of the distance between these two parallel axes. This is going to be very important statement. Okay, so this is the parallel axis theorem. Now similarly we will also talk about the perpendicular axis theorem in the next lecture. Okay, thank you.